Hello everyone and welcome to another episode of Investigation. As you've probably realized, I haven't been uploading frequently over the last few weeks. That's because I've been learning some video editing, and I will add some editing here and there throughout my videos. And I have already made an intro and an end screen that you will see with some background music for the videos thanks to First, and I will put his link to the description down below so that you can check it out. It's really amazing. And in today's episode of Investigation, I will go over derivatives constant rule. So the whole idea of constant rule is to eliminate all of the constants, that we can deal with all the constants over when we are taking derivatives. So we're basically taking the derivative of a constant that does not involve the variable that we're taking the derivative with respect to. So let's make an intuitive sense of it. First of all, we would have graph this function. That's not very straight, but they're perpendicular enough. So if there is a function that is, let's say, horizontal, because that's a constant function, and this function is, let's say, y is equal to k. And the definition of derivative is the instantaneous slope. But if you look at the slope over here, instantaneous slope over here, it will just always be 0, because at any point, you will just not have any rise over any long sort of distance. So this kind of slope would always be 0. So let's prove our claim over here with the definition of derivatives. So the definition of derivative is that if we define a function f(x) is equal to k, then f prime of x, or the derivative with respect of x, is equal to this d dxk, which we have as limit as h approaches 0 of f of x plus h minus f of x over h. And you've probably realized with our definition of f of x, that will just be k minus k over h as limit as h approaches 0, and k over k is just 0, and we know that every numerator, if that's 0, then that will result in a 0. So we've proved that our constant rule is true. And I will try a daily upload schedule from this point on to go over about 30-ish rules of derivatives over the next month. And I promise, after that, we'll go back to competition math. So thank you for watching this episode of Investigation, and we will see you in the next one. Goodbye.